Welcome everybody to the 15th International Conference on Human-Robot Interaction, sponsored by ACM and IEEE, also sponsored by ARM, Cambridge Consultants, XGware, Google, Honda Research Institute, ID Lab, and MDPI Robotics Journal. Now, some housekeeping for participants. Please keep your audio muted and your video off unless you're one of the sponsors. Put your questions into the chat and we're going to do our best to answer them in the Q&A time. We are recording the session and it will go on YouTube with the rest of the HRI 2020 videos on April the 6th. As you know, the official launch of HRI 2020 online will now be on April 6th because loading and reviewing that many videos on top of loading and reviewing all the papers for the proceedings took quite a long time. It's testing a lot of new technologies. And that's actually an exciting time, is because we're really seeing the real use cases for a lot of the technologies that we've been talking about. And we're seeing that in the robotics industry itself. It's still a struggle for early stage companies to stay afloat, particularly at this time when they're having to turn away from where they were heading for their business, and many of them are pivoting towards how they can help in a time of COVID-19. But we're seeing a huge demand now for robots for delivery, robots for disinfecting, robots for teleoperation, telepresence, telemedicine, and all of the advanced digital manufacturing technologies. These can all be incredibly useful during a time of pandemic. So we do expect to see an increased demand for robotics in the world as things move forward. I'm Andra Kay, and I'm the Managing Director of Silicon Valley Robotics, which is the largest association of robotics industry innovation in the world. And I'm also the co-chair of the HRI 2020 Industry, Exhibition, and Demo Program. So I am delighted to introduce the first of the HRI 2020 sponsors, Carl Faeser from ARM. And Carl, would you just like to start by saying a few words about yourself, and then we'll show your video.
Yeah, that sounds great. Thanks, Andra. I'm Carl Faeser. I'm the AI ecosystem evangelist for ARM, or one of them. There's two of us. And I'm going to be here to talk about a little bit what ARM does in AI and a little bit about NLP and how I see it.
Where we're seeing the future of ML going is taking ML that's traditionally sort of in the data center or in desktop or even in mobile and taking it all the way to an endpoint. So this might be an IoT device or a device that's at the edge. This could be industrial, consumer, but not requiring a network connection, but able to do inference and ML without requiring a network. And we think that's going to be very powerful and something that will proliferate ML an order of magnitude further than it is today.
I really like the music in that video. It's fun.
It's cheery.
Uh-huh.
So tell me a little bit
great.
more.
Well, I'm going to share my screen then, right? Mm-hmm. Yes. Let's see if I can do this now. I'm also going to try closed captioning, see if this works. Let's test all the technologies we can at once. Okay.
Wow. I'm impressed.
Yeah, this is part of PowerPoint, by the way. I just discovered yesterday while I was practicing for this. So we're learning so much about what we can do with the technology we currently have. Okay, thanks everyone for joining. Definitely thanks Andra and everyone at HRI for being able to adapt and shift this into what it is now. I've done enough events that know that even in the best case scenario, they're crazy and hectic. So thank you and congratulations for doing all this work. Let's see, who am I? That's me. I think that's ICML last year. I am an ARM AI ecosystem evangelist. My background's in cognitive science and artificial intelligence. Previously is with Samsung SmartThings, Mycroft AI, and Intel. And currently most of my work is around engaging partners and developer experiences around ARM AI products. What are those, you might ask? Here's a plug. ARM enables AI everywhere on every device. Everything from cloud to edge to endpoint. Or so endpoint is like IoT, edge can be like gateways, and cloud is obviously servers and things. But this just means that I'm going to talk mostly from a commercial and consumer perspective on this. Not so much research today, more kind of what I see practically happening in the world. And another key point, when I say ecosystem, this is kind of what I mean. ARM has a very large partner network. We can do nothing with our partners. A lot of our partners help sponsor this conference, and a lot of our partners sponsor other conferences, and we kind of tag along for the ride. But without our partners, we are nothing. So this is what I mean by ecosystem. And these are our AI-focused partners. We have a lot more than this. This is just some of them. Also important caveat, since I work for ARM and I speak about things, I'm going to refer to things as either Cortex-A class or Cortex-M class. So M class is going to be microcontrollers and low power CPUs. And then Cortex-A class is going to be larger CPUs that can run full operating systems. So Cortex-A is going to be like Raspberry Pis or smartphones. And Cortex-M is going to be microcontrollers. So like Arduino and all the very, very small processors that are basically everything. Okay. History of NLP as I see it, or natural language processing and voice interfaces as I see it. Very long ago, before time began, people had dreams of talking to computers. Early in the days of computers, there were ways to speak, but it was very rote translation of say this specific word and it will translate it to text maybe, or say this specific word and you will get the specific action, or say this phrase and get this action. It's very much a one-to-one correlation, very programmatic, very knowledge-based system-y. And that brings us to 5 years ago, which is kind of a revolutionary moment, the way I consider it. The Amazon Echo came out, and it was kind of this rise of neural networks and intent parsing for controlling voice interfaces. And this made A, things a lot easier for the developer, and B, things immensely easier for the customer or the interactor on the other end, the human who's interacting with this device now. These things make everything a little more flexible. You can use some of your own more natural speaking techniques to talk to now inanimate objects, and huge deal. I was at Smart Things when this happened. I worked on our housing integration with the Echo team to make the smart home actually start to make sense, because before you had to control it with an app, and as soon as you plug an Echo in, then you can control your lights with your voice. Great, it made way more sense. But that was it. Echo kind of came out of by itself. There were other voice things around, but it kind of changed the game in my opinion. I'm not saying the other ones weren't great. I'm not saying they don't have a place, but I'm just saying this one kind of changed it in my mind. People started talking to their speakers, which hadn't happened before, unless you were, very interested in the music or you were appreciating the speaker for the way it looked at you in the morning. Cloud adjacent is what I call now. I should also say 5 years ago, cloud dependent. All this processing was done in the cloud. When the Echo first came out, I believe the wake word detection was still done on the cloud. So basically all your voice was streaming up to the cloud, and then they cut that back and started doing wake word processing on the device, and then streaming everything for processing and intent parsing in the cloud. And that's still the way it's done. Now we're moving more to cloud adjacent. So we have wake word detection on your local device. And a lot of that is thanks to the new technology trickling down. We're also getting more intent parsing on the device as well, even small devices. So there are a lot more voice devices out now. Google, Sonos acquired Snips, who was one of our AI partners, but now they're going to go build interfaces for Sonos, I'm assuming, because that's what they did. The Apple HomePod Siri, which is the only one pictured here that is not one of our ARM AI partners. And then other companies like Pico Voice and Babel Labs who focus on voice control for microcontrollers. A lot of this is due to the democratization of machine learning. TensorFlow is very popular, and now thanks to things like TensorFlow Micro, anyone can do machine learning on microcontrollers. There's also machine learning on Cortex-A size devices. I'm just very impressed about the machine learning on microcontrollers now. There's also autocompilers like TVM. So basically the field is ripe and ready to kind of make this shift from the cloud to wherever you need the processing. And companies like Pico Voice and Babel Labs are doing that. Pico Voice does intent parsing and speech recognition, and they actually have a model that can do 200 intents on a Cortex-M device, so a microcontroller, and completely doesn't need a connection, but it's able to do 200 intents, which is basically where Amazon Alexa was 5 years ago. It can, depending on how you train it, it can interact in different ways. And Babel Labs is another one of our partners. They do things like noise cancellation and reduction and focus on making microcontrollers better at hearing you. So 5 years from now, this is my prediction. I can be very wrong. AutoML will be more popular and actually usable. Right now, it's still fairly new and doesn't quite work right, but in some cases, it kind of works great. I also see a rise of more things than voice. So right now, it's very voice interaction heavy. This is not great for a few reasons. One, people with disabilities, for some reason, any kind of disability where for some reason they can't talk or listen, this kind of leaves them out in the dark. If you can have more kinds of intent parsing, like visual intent parsing or wake wording, visual wake words is what I've heard it called, which makes not a lot of sense to me, but I understand. So I see these things moving more, taking these similar techniques and apply them to something else besides voice. Also other things like more than intent. Right now we're very context poor with our interfaces, as in they sometimes know who you are and where you are and what you did before, but that's not always the case. There's also a lot more information that could be gleaned by other things in the environment. I also see specialized voice interfaces per device, because right now it's kind of, there's Echo and Google Assistant, they're kind of one size fits all, but these don't quite work in all environments, or you have privacy issues and you want to run everything on a device, or you don't need your microwave to play music. You would rather it just microwave something, or your bedside clock doesn't need to order you more ketchup. That doesn't make sense. So specialized per device interfaces, which hasn't really taken off yet, but I think due to everything getting easier, interfaces getting easier to build, a voice interface or some kind of visual interface is going to become as common as like an LED screen on devices. Now, why do I say that? Two reasons: software and hardware. Right now, software is very fragmented, and I'm going to show ARM slides, but this is kind of becoming industry standard. I just have these, and we're definitely working on this. So right now, it's very fragmented. You train your neural network, you build your application, and you have your operating system or whatever the functions are that you need to keep your computer running. And these things are very separate and fragmented, and you do them all in separate work. Normally, it's different people building these things. In the future, these things will get more integrated together. So you're going to get performance increases. It's going to be easier to build. And your neural network and your application are going to be more built as one thing. And also optimized for your hardware, which leads me to hardware, because we're a hardware IP company. So the other thing is there are neural network accelerators out now. They've existed for a while. Intel Mobility first, Google Coral released theirs, NVIDIA Jetson, and now there's also other like startup companies building microcontroller sized accelerators. We at ARM are also building our own, including the Cortex M55 and the Ethos U55, which are micro-sized neural network accelerators. And I like this graph because it kind of shows everything on a scale in terms of complexity, in terms of machine learning, and how much power in processing do you need. And this is, a lot of these devices, the IP is out and being licensed, but they don't exist yet. Within the next 3 years, they will, as well as companies all over the place are going to be building them. But basically all this neural network processing power is going to be localized on device, and the software is going to be easier, and we're going to be able to build all kinds of things, or everything on the call is. So that's it. Next steps, I would say, if you haven't yet for some reason, take a dive into ML. It's easier now than it's ever been. Visit developer.arm.com, apply for our AI partner program if you're building something amazing, and also try TVM. It's new. I think it can go far. And right now the community is relatively small and could use help. And that's it. Thank you, everyone.
Wow, thank you so much, Carl. I think putting things into perspective as you did with that last graph, showing where things are going in the next 3 years, in the next 5 years, and what the intent is, gives us a chance to work out how to move forward, really, to see, as the famous saying goes, to see where the puck is. And if you've got questions for Carl, put them into the chat. What I'm going to do now is I'm going to ask Chris Roberts to give his presentation as well, and then we'll try and do a little bit of joint Q&A before the next speakers, and we have a poll as well. So Chris Roberts, would you like to introduce yourself and Cambridge Consultants?
Sure, yeah. I'm Chris Roberts. I'm the head of robotics at Cambridge Consultants. We're an engineering design services company. So what we do is design products for our clients. Anything cutting edge, anything new that hasn't been done before, that's kind of some mixture of software, electronics, mechanical design, mathematics, algorithms, any multidisciplinary thing. That's the sort of stuff we do.
So hi, I'm Chris Roberts, and I'm here to talk to you about the challenges of human-robotic interaction in the real world. But before I go into that, I thought I'd start with a quick story. This is from a couple of years ago, 2016. I was working on a robotics project. This person you see here is Anita. She's a character from the TV program Humans, which was first broadcast in 2016 in the UK. She leads a group of self-aware robots, and the only way that you can tell she's a robot and not a human is that she's got bright, glowing blue eyes. Other than that, she's completely indistinguishable from a human. Around the same time that this was being broadcast, I was working on a project to do fruit picking with a robot. And I'd been working on it for about 6 months, and with a team of about 5 very competent engineers. And we just about got the robot to pick up an apple. Occasionally it dropped it, and it certainly couldn't manage to pick up a strawberry, let alone getting anywhere near to overthrowing its human masters. So this story just illustrates the big gap between the public perception of robots and the reality of what you can actually achieve. But you guys are robotics researchers. I don't need to tell you that. But what I do want to tell you is there is often a similar gap between the sort of things you can achieve with robotics in a very controlled laboratory environment and the things you can achieve in the real world when you have to deal with lots of variation. And I don't think that gap comes from a lack of realism in the research community, for example. It's more that there are a lot of things that you don't need to consider when you're doing research that you do need to consider when you're producing a product for commercial realities. And I'll explain more about that later in the talk. So, introduction to me. I'm Chris Roberts. I'm the head of industrial robotics at Cambridge Consultants. The work I do is all about bringing automation and robotics to new areas, doing things that haven't been automated before. And that typically means combining robotics with other sensing. So maybe machine vision, maybe we have some classical algorithms, maybe we have some AI, maybe we do a lot more sensing than we used to do before. But anything where the robot needs to deal with a changing environment or objects that aren't always exactly the same. And all the projects I work on are kind of at the D end of the R&D spectrum. We're always focusing on getting something that has kind of commercial relevance to our clients. They're going to sell the product we we design for them. So it needs to make money. So the company I work for, Cambridge Consultants, we are mainly based in Cambridge in the UK, although we have offices around the world. There are about 550 of us based in Cambridge and 800 in total. The way that we work is our clients pay us for our time, and in return they get intellectual property, they get a design, they get prototypes. We'll help them find a manufacturer, but we don't manufacture and we don't sell the product itself. We sell the design to our clients, and then our clients sell the product. So the sort of projects I'm working on at the moment where humans and robots need to interact are those projects where the robots are kind of doing semi-structured tasks. So the difference here is, if you imagine a robot on a production line where it's making, when you're making silicon chips, as the devices roll off the production line, they're always the same shape, they're always the same place, and the robot just has to do the same thing over and over again. If you contrast that with picking apples, for example, there isn't a blueprint for an apple. An apple might be a different size, a different shape. It might be moving about in the wind. It could be raining. It could be dusty, dirty. Leaves could be getting in the way. So that's a semi-structured environment. You know the apple's going to be roughly on the tree somewhere, and we're always dealing with the same thing. We're not trying to be too general and have a robot that can do everything on the farm. But it is structured, but it's only semi-structured. And the tasks that we need to think about in order to get a piece of technology from idea to product is, although we need to solve the kind of the hardcore robotics problems, we also need to deal with some rather prosaic real-world constraints. So that might be the fact that the robot needs to fit in a constrained space. Maybe there's an existing room that it needs to be in, you can't change the room. The robot needs to be designed to be easy and cheap to maintain and repair. Maybe it needs, and then one of the strongest constraints is usually cost targets. And those come out in two different ways. It could be a cost target in terms of hardware. So if you're making a lot of these, if the product you're working on is going to be replicated lots of times, then usually the biggest driver is the unit cost, how much that hardware costs to produce one copy of it. On the other hand, if the thing that you're working on is in low volume and you're only making a few dozen of them, then it's probably the development cost that is more important. So how much you need to pay your engineers, and whether that's a company like us or your internal engineers, how much engineering resource you need to do to get to a product. My biggest challenge is working out how to make a flexible and interactive robotic system that still meets all these constraints and yet remains safe and provably safe, so that it can be CE marked and it can be people can interact with it in a safe way. And that's some of the more interesting challenges that I have to deal with at the moment. And I thought I'd illustrate this by talking to you about two of our projects that we've done recently. The first project is an internal one. This is about mobile robotics. That's something that we are investing in internally. The second project is a food technology project that we did for a catering company. That one's an external project, one that we did for a client. So I'll focus on the mobile robotics one first. So this is a project that we're in the middle of right now that's all about navigating through crowded spaces. So this is an internal investment, so this is different to some of our commercial projects in that we are developing something that will grow our skills and capabilities in-house. So we're not developing a specific product, but instead we're trying to build a platform and an architecture that can be embodied in different ways. And the sort of applications we might consider using this technology for are connected venues. So, for example, an airport or a theme park, where it would be great to have a robot that can be very useful to the people who are enjoying this experience. Maybe it's an agri-tech application where we've got some robotics in the field, or construction one. And the embodiment for those three different applications might look very different. So, a shopping mall application, you don't need to worry about bumpy ground as much as you do in an agri-tech environment. And equally, in a construction environment, you don't have to worry about things like opening doors and going up staircases, but you would need to worry about that in the shopping mall. And as we go through this project, for us, it's all about growing our expertise and our experience. And to do that, we need to look at lots of different technology components. And those will include things like the technology needed to follow and avoid people, mapping and location, both in terms of knowing where you are on the map and knowing how to update the map, and then plotting a route from the point you're at to the point that you want to be, and coping with changes along the way. The electromechanical aspects of the robots, such as the motors and drive trains, how the power constraints work. Do we have a large battery and long charging cycles, or something smaller that's more rapid to charge but needs to happen more frequently? The sensors and communications from the point of view both wireless electronic communications to other machines, but also the user interaction, how it communicates information to people, and how people communicate information to it. And then obviously the concerns around safety and stability of the robot, so it doesn't topple over and hurt someone, and security, so it can't be hacked or stolen easily. And as we started looking through those technology components, the key theme that we wanted this robot to embody was interacting with everybody. And when we broke that down a bit further, we looked at what interacting meant. And so that was all around kind of how the robot communicates intent to people, and how people can communicate to the robot, how it successfully shares space with people without colliding, and interacting with people much more in the way that you might interact with another person, rather than the way you interact with a machine, because it's got to navigate through crowds. And then we looked at the other side of that phrase, the everybody side, and we realized that there is a lot we could do about interacting with adults versus children, able-bodied people versus people with disabilities, groups of people rather than individuals, people that are kind of aware of and know the robot versus people who are encountering it for the first time. And once we started getting to this, we realized there was a huge amount of things that we could do. But because this was an internal investment, it was important to us to focus on doing the right thing. We wanted to choose one particular aspect and do it well, rather than try and do a little bit of everything. And that's the right way to go about things when we're considering an internal investment. So to start with, we thought about, we'll narrow the use case down to being an interactive experience. It provides information to people and helps them move through an airport or another crowded area. But that seemed to be too much, really, to implement on our first thing. It wasn't the minimum viable product, so we narrowed it down a bit more, and we came up with the idea of a robot that leads a group of people through a crowd. And even that, actually, when we worked out what we would need to do to implement that, even that use case was a bit too broad. The use case we're focusing on right now is the robot navigates from point A to point B when the area is crowded. And now, when I set this project up, I didn't expect that sourcing a crowd was going to be one of the more difficult parts of this project, but that's the world we live in at the moment. But having said that, there's still lots of stuff we can do. and getting these things right in simulation, and then understanding how that simulation interacts with the real world and what things it's good at modeling and what things it's not good at modeling, is the sort of process we're going through right now. So that's the mobile robotics project. The next project is the catering robotics. Now this one is different because this was from an external client. The client came up to us with the challenge. They wanted to create twice as much business with the same number of staff. So this was a large catering company. I can't tell you who it is for confidentiality reasons. But they were a big company, €2 billion turnover, and they were a traditional company. They employed people to go into canteens and schools and prisons and run the kitchens in those places. And they were struggling to recruit people and retain people. They had a high turnover of staff, and they were losing business to smaller, more agile companies. So this is a bit of a theme with our robotics projects. In general, although you hear a lot about it, people aren't designing robots as a way of saving money by making people redundant, but they're generally being used as a force multiplier, so you can do more with the staff that you do have and redeploy your staff onto more interesting jobs that are more suited to people, while the robots do the boring stuff. So we were starting with a completely blank sheet of paper. They wanted to increase their business, but they knew technology was the answer, but they didn't know what to do. So we came up with 3 possible projects for them. One around automated cooking, one around automating the logistics of vegetable preparation, and one around automating dishwasher loading. So the first one, and I'm going to show you a video of this, is the automated cooking robot. And this was a really interesting project. It was a great example of something that is completely technically possible to do. So we built this prototype, but when we looked at this in the real world, although technically it was perfectly possible, there's a lot of real world issues that stop this being the right thing to do from a product point of view. Actually, chefs don't spend a lot of time cooking. They do lots of other tasks. So just automating the cooking bit doesn't really save the company any money. And cooking's a hard thing to automate because you've got natural variation here, and if you use the same inputs, you don't always get the same outputs because different water content, different sizes of vegetables, and so on. Although we built that prototype, we didn't take that one any further. The next project we looked at was the logistics of preparing vegetables in the morning. And we initially thought that this would be a good task to automate as well. There's lots of gadgets in the kitchen that do some of these tasks in a low labour way. Maybe we could come up with an idea of a robot conceptually combined with a food processor. So you could put kind of whole ingredients at one end and then wait a while, magic happens, and then out pops chopped onions and prepared salad at the other end. But actually, when we looked at that, the more important thing was not automation, but centralization. So the simulation you see here is looking at the concept of, instead of each individual restaurant preparing vegetables in the morning, let's prepare vegetables in a central location and then ship them out to individual restaurants. So they're ready to be cooked in the morning. This is something they do a lot of in Spain, for example, but not so much in other European countries. And the simulation showed that there was a sweet spot somewhere in the middle. The more hubs you build, the more the costs of those hubs, the total cost goes up, but the less you spend on transport. And if you've got a few hubs, you don't have to spend so much in setting them up, but you spend a lot on transport. And the simulation we did here showed that the sweet spot was somewhere in the middle. And this was this was interesting because although, again, technically it would be possible to implement a robot to do this, the real money-saving thing came from not from the automation, but from the centralization. So this one didn't go forward either. But the final task we looked at was dishwasher loading, and that was a really good one to automate. Most of the dishwasher process is already automated, and loading the dishwasher is the job that everybody hates in the kitchen. People dream of being a chef. No one dreams of being the person who loads the dishwasher. Nobody wants their children to do that job. But it's tricky. The graph we've got here, this shows the tasks that different staff members did. So each vertical bar here is a different staff type, from head chef on one side to plongeur on the other. And each of the different bars is a different task. So you can see that each person spends their day doing lots of different things, and each task is spread across lots of different people. So this is just to illustrate it's really hard to automate. If your goal is to kind of take the staff that would normally run one restaurant and then use that same number of staff to run 2 restaurants with some machines, that's quite difficult to do because there isn't one task that you can automate. But the biggest task, and one that is possible to automate, is the loading of the dishwasher. Most of the dishwasher process is already automated. The bit that's tricky is the bit at the front where you take a tray like that, and then you need to identify the crockery that's on there and the cutlery, take them off, and put them in a known location on the way into the dishwasher. Because the dishwasher's in a commercial kitchen, they're not like the domestic ones at home. It's a conveyor belt process. You need to stack the plates into prongs, and then that's a sort of continuous motion. And after 3 minutes, they come out the other side of the dishwasher and they're clean. But it's really hard to identify where the objects are because they're not always in the same place. They're not always the same shape. They might be covered with food waste. And then you need to pick them up. And picking them up is tricky as well because they might be slippy, they might be dirty, they might, it's hard to make a good seal. So the way that we were able to succeed with this was a combination of electromechanical design of the gripper. Pinchers don't work, but this sort of continuous vacuum gripper is successful, and you can make it out of stuff that is food safe and it can easily be washed and replaced. And this combination of that and AI working together was the only way that we could get something that's fast enough. So to sum up, I think my experience shows that getting the prototype to work in the lab is just the first step. You might think you're 90% of the way there, but in reality, you might be 50%, you might only be 10% of the way there. There's a lot of things to do from kind of first working prototype to product. And that requires a different set of skills. You need to make sure that your design is providing a benefit that is commercially relevant and not just solving an interesting problem. I was really looking forward to building the veg preparation robot, but actually that wasn't going to solve the problem. If we could, instead of saying, well, what's the best way for this restaurant to prepare vegetables with low labour, that wasn't the right problem to look at. It was a question of looking at something much broader. And then the right answer wasn't robotics, it was centralization. And the challenge is often overcoming the real world constraints. The hardest thing is not necessarily the robotics or the mathematics or even like things like algorithms. It could be something as dumb and prosaic as, can you make it small enough to fit in the existing kitchens? Or and cost will always enter into it. The work we did on the dishwasher only made sense because the client had 1,000 sites. So if it cost us, say, 10 million euros to design the dishwasher robot, if you're only installing that in 10 sites, that adds €1 million to the cost of each machine. If you're installing it in 1,000 sites, that adds €10,000 to the cost of each machine, which is much more realizable when the person that you are replacing with this machine the money you're saving is maybe 25k euros a year. So 10,000 euros is a much more realistic number to add for research and development. But having said all that, it is an exciting time to be working in this field. There's lots of new technologies that have reached the point that they're ready to come out of the labs and be implemented in products that have real commercial relevance. So if you want to know more about what we're doing or the projects we're working on, then please get in touch and I'll be delighted to talk to you more. Thank you very much.
Thank you very much, Chris. And those were fascinating projects. And I think we've got a lot of questions already bubbling into the chat about how you implement those. Before we have more presentations, let's just take a few minutes for any questions for Chris and for Carl as well. And we'll try to field them from the chat, but you can also, we have a poll, and I'm not quite certain if this is going to interrupt the chat process, but I've sent the poll out there as well now. So many of my questions were actually answered by both of your presentations. I do think that, back to something, Carl, that you said right at the start about how Echo was really a game changer. It absolutely was. It was fascinating for me because there were a lot of social robots that were launching or trying to launch at that time, and Echo just blew them out of the water, which in some respects was a bit of a shame. But on the other hand, it really showed that nailing one thing well at a price point and getting it to market was better than trying to come up with a fancy robot that was going to be more expensive and more trouble prone. And I think this is what we see with robotics across the board. Right now, it's really more important to solve one thing well. And do you have any insights from what you see as to the sorts of problems we should be looking at to solve with robots?
I don't know. So a few years ago, there were a lot more teleoperation companies, especially operating in Silicon Valley. And they were basically like Roombas with iPads, and you could do remote work, and it's kind of telepresence. It was more telepresence, I should say. And those kind of disappeared. And I would be basically what the situation we're in now, I personally would have expected to see those companies come back, or to see a resurgence of those type of work companies, or see some of the current robotics platforms that exist, like the Baxter, being appropriated into medical work. And that doesn't seem to be happening, maybe because the time frame is so short and the need is so urgent that they're just making do with everything they can. But it means that I'm somehow wrong in my thinking, and I would have expected an explosion right now. But I think it's exactly what you said. Like, these companies were trying to do everything all at once instead of focusing on a specific problem. So maybe now the focus is going to be solving the specific problem of like medical, like having a nurse be able to work with patients safely, and like maybe that's through like an intermediary robotic platform. And maybe that problem, and it's just a way to, and they focus just on like communication, like simplifying the problem, getting the cost price set down, and making it easy to use for the nurses involved. And that way, when they do need to interact with a patient manually, literally with their own hands, then they can still do that. But for the most part, they can still be safe. It also might open the doors up for having a flexible, like as we're seeing now, you don't need to physically be together to interact with each other. It might open the door for more flexible demand of medical labor, basically, like being able to rise and flow demand when, like, say for example, if every nurse in the world had reacted to this in the beginning by dialing into Wuhan and helping with the quarantine and helping the patients there, maybe this could have been reduced a little bit. But that's purely like speculation, but it's possible. So maybe it's focus.
I think, yeah, that's really interesting. One of the things that I see that we work in consumer and industrial markets and healthcare, medical technology ones, and there's a real split between the robotics you see in medtech and the robotics you see in a more industrial or agricultural environment. In medtech, the robotics that at least that we're working with is all about replicating the surgeon's movement. So in surgical robotics, there's very little autonomy. It's all about doing exactly what the surgeon does. Maybe there's a bit of kind of guide, so you don't sneeze and chop someone's arm off, but it's there'll be tremor reduction, and maybe the surgeon's making big motions and the robot's making tiny motions, but it's not autonomous. There's very little autonomy. Whereas on the other side, on like agricultural and industrial applications of robotics, I'm not seeing people. You hear a lot in the media about robots stealing people's jobs, and the companies that are approaching us are not coming at it from that point of view, because robots in general aren't cheaper than people. At least initially, they're more expensive. And so people are only looking to automate tasks when they can't find the labor, where there's a labor shortage. It's being driven that way around. And the tasks they're looking to automate are kind of the next level up on the scale of kind of boring, repetitious, simple tasks. So, for example, picking parts off a conveyor belt in a production line, that's already pretty automated. It's quite hard to pick apples from a tree, but that's quite a structured task. You can imagine that being automated, and that's the sort of task that people are looking at automating now. But there's a real emphasis on low cost, because what that's replacing is a relatively low paid worker.
Well, I think cost is something that's come up over and over again. And I have to say that in terms of funding is what I also think of. And the world is really very difficult in terms of funding for robotics companies, because Carl, you were mentioning Baxter from Rethink Robotics, and sadly Rethink Robotics closed its door a year ago. Also, Suitable Technologies, one of the most advanced telepresence robotics companies, closed its door a few months ago. So there hasn't been funding, or let's say there hasn't been patience in a lot of the funding for robotics companies to see them over the kind of the point at which they are trying to develop a new flexible or good enough robotics to be useful, and that's tended to be a little bit too expensive for the market point. And just talking about the poll result that we just had, from the perspective of human-robot interaction, what kind of technologies do we want to see? And if there's a technology that was not on this list that you want to see, please put it into the chat, because it kind of, I was scratching my head thinking about what to put on this. And the hands down winner of the poll was affordable robot platforms. And I am certainly seeing companies doing this. These days, I believe it is possible to effectively create an autonomously navigating mobile robot for about $2,000, to purchase a 6 degree of freedom industrial grade arm to go on the top of that for about $6,000. This is US dollars. And to have an industrial grade gripper on the end of that arm for about $1,500. So all said and done, you've got a totally full stack robot solution for less than $10,000. It probably is a little bit of a jump for a user to be able to, you're probably programming that yourself, shall we say, but it means that the base platforms are affordable. And indeed, the teleoperation, many robot companies that I see are working on dashboard, fleet management, and teleoperation now, as we see these becoming needs for the growing industry. But Chris, you had a number of other questions in the chat there for you, but can you just talk about your design process first?
Yes, I can. That's actually quite a hard question for me to answer because because we're a design consultancy, we work for a lot of different clients, and the projects we work on have a lot of different scales and challenges. So the design process that is suitable for one client is not suitable for another client. So the design process we'd use to get a wearable device that needs to be on the market in 9 months is very different to the design process we'd use for a safety critical medical robot application, for example. Having said that, the kind of we do follow a process that ensures that we there are steps to our process which are the same across all these different types of projects, and it's all about finding out how this product is going to be a success, and so that is understanding all the requirements that the client needs up front, and so that could be technical requirements, it could be commercial requirements, it could be process requirements. It's no good making a safe product if that product is not provably safe, and so it can't get onto the market. And then having established what the needs are for the project, then there's a step of addressing the riskiest parts of the problem first. So if you needed to build an anti-gravity car, for example, you need to build the anti-gravity bit first. There's lots and lots of engineering you need to do to make the car, but that's kind of, although it's quite expensive to do, it's not high risk. It's been done before. Teams can do that. No one's built an anti-gravity device before, so that's the thing you have to tackle. So you hit the biggest risk thing first, and also, when a client's working with us, they're spending money for every hour we're working on the project. So in some ways, a quick stop is as good as a successful result out the end, because it means they haven't wasted money. So again, exactly what we're doing will depend on the project, but through the design process, it's all about reducing risk, and the more time goes on, the lower the risk gets. And then at the end, it's if we get that far and we've got a product, there's the stage of kind of going from prototype to from a looks like to works like to something that's exactly the same but made in a completely different way. And then finally, hopefully, something that is coming off a production line, and then it's just built to print. So there's not much detail, I'm afraid, but
you did raise a very interesting point, which is that about the risk involved when you're creating something that is a very new process. And I thought that's a really good introduction, actually, for Ke-Jiun, because you've got something that's very new. And I'd like to hear more now from Ke-Jiun Wang from XGware. Did I say that correctly?
Yeah, that's perfect. Can you hear me now?
Yes.
All right. So hello, everyone. I'm Ke-Jiun Wang. If you feel my first name is hard to pronounce it, you can call me Kenny-G, that's fine. I'm currently located in Pittsburgh, but I'm originally from Taiwan, so I'm very glad to be here in Pittsburgh for almost more than 10 years. So our startup company is working on the wearable solution that can merge human with the AI smart enabled device seamlessly. Particularly, we are developing like an earbud device, because we think the ear is actually a very good human AI or robotics interaction channel, because we can capture a lot of signal from the muscle or inside our ears, like EEG, EMG, or EOG signals. So for instance, if you touch your back of your ear when you are speaking, the muscle is still moving, right? So I think this signal, we can capture that. So whenever you do some smiling or do some blinking, we can capture your very significant signal, and also left and right or up and down. We can also capture signal from around your ears. So probably some of you heard that there's an MIT student. He developed a silent speech device to capture the signal. I think it's the EMG signal from the chin. So when people want to speak, he can do some very micro facial expression, like do a very tiny movement inside of your mouth. So that signal can be captured by the EMG sensors. But we believe we can capture that signal from around our ears too, because our muscle is also moving. So somehow it's a general direction. We think we can benefit a lot of area, such like we can control the device by this kind of micro movement or EEG signals. Particularly, we also combine with the some additional sensor like a gyroscope or accelerometer. So when you are looking at a certain direction, like there's a light bulb over there, when you look at the light bulb, you pause a little bit, pause a couple of seconds, and when the accelerometer signal is going down and you blink your eyes twice, you can turn it on or off, such like that. And also we can identify the emotion or stressfulness by this kind of device. We put the sensor inside the ear, and there's a lot of literature about you can map your brain signal into your inside your ears canal. So we can put a different sensor around our canal, and we can identify different like a stressfulness or emotion, or even heart rate, or your like a PPG sensor, like Apple, the AirPod is doing right now. They are putting the sensor inside the earpod. So in the future, we think the earbud will be a very good wearable device that can merge human and the environment all together. Like Chris, you are wearing a earphone right now, right? So that earphone probably in the future will embed a lot of sensors, so we can measure your emotion, what you are thinking right now, if you are stressful or not. And the smart digital intelligent assistant will tell you, okay, you are very stressful today. You had to do a lot of exercise. You had to listen to this kind of music, to talk to more people, to relieve your stressfulness. Especially right now for coronavirus, a lot of people are segregated from each other, and they are like self-quarantine or self-isolation, to self-isolation. So right now, I already hear a lot of people, they are yelling in the midnight very loudly. They open the window, they yell very loudly, very, very sad situation. So this kind of stressfulness will cause a lot of problems, like PTSD. This kind of syndrome will, in the future, I think will be a lot of problem. So I think this kind of device can like give the people or the human being a additional option that we can provide some AI algorithm built on top of that to give people additional support to relieve their stressfulness or control any smart AI-enabled devices in their environment. That's what we are doing right now. Because we are a very tiny startup company, so we cannot disclose a lot of detailed market or detailed form factor we are doing right now. But general direction is pretty much like that, to build a human AI communication interface from around our ears.
Wow. That's very interesting. And it's just taking the point, I was just saying that the timeline that Carl talked about at the start, you're diving right into the mining other modalities to develop new forms of interaction. And
yeah,
are you deploying any devices at the moment?
Right now we have some. We are getting into several startup accelerators, so we are exploring different market segments and some investment from some of our collaborators. But we are still scaling up. I think in the future, very soon, we will release our like a first generation to test out this kind of concept on the market pretty soon. We are both the hardware and software company right now, but the most important part is the software machine learning, because this kind of signal you have to generate a very accurate identification result, right? So we are building up a cloud-based. Probably in the future, we're using edge device, like using ARM processor or something like that, to build a edge computing device. But right now, we are using some cloud computing and some semi-supervised learning or self-supervised learning, or even GAN to explore this kind of reconstruct a very accurate brainwave signal or physiological signals right now.
Oh, excellent. So any questions for Ke-Jiun, please put them into the chat. And in fact, if you have any suggestions, you know, at such an early stage startups, introductions, funding, all of those things are super useful. So if you have any suggestions like that too, please, please make the connection. And what I'd like to do now, Tony, are you there still? Would you like to say a little bit about ID Lab?
Hi. Oh, I've still got my HRI background on.
Nice.
Hi. Jim is there as well. He's Jim, you're still on mute if you want to just say something. So Jim and I are the general chairs of the HumanRobot Interaction Conference, and thanks, by the way, to Andrea and people who just spoke up. It's absolutely fascinating to hear what your take is and what industry's take is on where robotics and where processing is going, really, you know, perceptual processing. Being an academic, we very often are at the other end, and so it's refreshing to hear what it is that you need and what it is that you're working on. There is quite a bit of overlap, and for example, in our group, one of the things we're very interested in is building neural models that are very lightweight, and we're looking at new ways of trimming down neural networks to fit on mobile hardware. For example, to build systems that can recognize sign language, and but kind of I want to talk a bit about the conference itself. So the conference is a very broad church, and we bring in lots of different people, not only people who work on the technology to support human-robot interaction, but also people who work on the way people relate to robots. So taking more social psychology standpoint, we work with psychologists, sociologists, philosophers, looking at how we interact with machines. And what I'd like to know, and it's a shame if we can't meet in person, but what I would be really keen on is understanding a bit more what people in industry could learn from talking to this very broad group of people. So at the conference, if you would have joined us, you'd have seen a large group of psychologists looking at interaction, how we what our stance is towards robots, what our stance is towards interactive devices, how communication breaks down, how when we trust devices, when that trust disappears. Is that something that industry is keen on hearing more of, or is that something that that perhaps is just too academic at the moment? Is it perhaps too early for developers such as you to engage with those topics?
Now, Carl, if you can speak, you might be really the point person for answering that question. I do think, from my perspective, seeing many startups come through, we have human-robot interaction experts totally appreciated by the autonomous vehicle community, but they've got a lot more money than a lot of the early stage startups. And so what I find is that there's a real gap usually in the ability for early stage startups to leverage good design, good principles, and so forth, because they're really focusing on solving one problem. And that's not just building a technology, it's actually finding funding and finding a market for that technology. And if we think about the entire internet on which we're building things is still primarily funded through advertising revenue, as opposed to many of the really great global challenges that exist that we would like to be working on. And I do think one of the really optimistic possibilities for robotics is that robotics has the potential to solve global challenges in a really significant way. But it can be very difficult to see that when you're looking at one interaction or one startup. So we need to have conferences like HRI 2020 to look at the whole community and the whole range of initiatives that are out there.
Yeah, I would definitely, yeah. No, go ahead if you have more.
No, I was going to say, and Carl, over to you.
Yeah. No, actually, yeah, I definitely would agree. I would say my first background was in philosophy and cognitive science and studying human cognition. And I feel that was very, very worthwhile before moving into artificial intelligence research. On the flip side, it took me a long time to get there, and I was in school for a long time not building things. I think human interaction design is often neglected in new technology startups because it's seen as like a secondary need to something like a CTO, where you need that hard tech first. And one thing that I'm going to cite Apple because they do user design like nobody's business, and they have a huge, massive amount of teams focused on human interaction design, and they do interactive design very well, and they're very slow behind the curve in terms of, I would say, like building voice assistants and smart speakers, but that's then because they focus on the user interaction side first and the technology second. Like if we want to focus more on this kind of human interaction, then the technology just enables that, and you need to focus on that, solving the problem of the interaction itself. And that's not something you can solve with technology. It's going to be user research. It's going to be all these like alpha beta testing, like more classical psychology kind of systems, and less on the technology side. Yes, the technology is important, but it should be enabling, like your primary function should be like that thing, which is the interaction between those two, if that's your focus. A lot of times, like there's still a lot of work to be done in mechatronics and the technology behind it, but I think that's why a lot of these companies they're focusing on solving the technological problems and not the human problems.
Okay, and Kejun, I'm going to ask you also to chime in here, because what I do think is a possibility is that we're going to see new devices entering the market, new opportunities and new modalities. And it's probably really critical when we're introducing new technologies like the sort of emotional detection abilities that you're talking about. And it's probably really important to have a sort of validation from the community of human-robot interaction. Or it could be that the human-robot interaction research community is the initial market as well, and where you find the real development happens. How do you see the interaction with HRI?
So I think the most important part as a startup company is to find the critical problem that people are experiencing, especially for the futuristic, like our device is very, give people a very futuristic experience. They are never experienced before. So in this kind of situation, that you really need to have a very good experience design, like a human-robot interaction experience design, to give people a very good feeling or similar like feeling that they are willing to use this technology for a long term, but not just for a couple of minutes or couple of days. They will get rid of that. I think it's not a I think the difficult part is really like this one. But we are really seeing more and more humans' behavior are changing with the technology development. They are really more and more accept willing to accept this kind of new technology, especially for the young generation. They are not as the old school people. They don't want to use this device, but they are willing to try, and they are willing to experience this new technology. So the human behavior is changing with the technology development. Then also with the coronavirus outbreaks, I think people has more and more problem over this emotion side of things. So the human's behavior is dramatically changing because these kind of things happen. So the technology will find its landing ground with the new behavior. So I think, I think our technology has a lot of difficulty right now. It's very complicated still, but with more and more this kind of acceptance from the market and the new behavior has changed, I think we more and more has more opportunity in the future right now. Yeah.
If I could quickly jump in, can you hear me?
Yes.
Yeah. I'd like to say, first of all, I'm really excited to see this event, and thank you to the whole crew and the exhibition chairs and Andra for putting this together. I've been going to HRI, the conference, as an academic for a long time, and I think that the way I see the problem of robotics and human-robot interaction is I don't see it as a design, as a technology problem anymore. I find the technology problems I'm hearing people talk about, many of them I heard 15 years ago. And so I look at this instead and I think, well, I think it's a design problem. And I think we need, and as Carl was saying earlier, we need to rethink how we're applying this technology to our lives and solve real problems. So the reason this makes me excited about this event is because the research community, we're really good at honing in, narrowing in on one phenomenon or one narrow problem, one technical challenge, and solving it or learning about it or doing, within all these constraints. In my own research, we fix this, we fix that, we fix this, we fix that, and we learn something. But I think industry has this really exciting potential to throw all that out the window because you don't need the p-value or the publication and go, wait, we learned this, we learned this, we learned this from what the researchers are saying. We're on the ground, we can talk to people. And I see this real potential for innovation from industry to take what the researchers are doing and make it real. So this makes me really excited, and I hope that as HRI continues, we can continue to grow this connection with industry that we've really springboarded this year. Carl was earlier mentioning Apple. It's funny, I'm a huge Apple fan as a person who doesn't use Apple products. But I think they've done this fantastic job of putting interaction first and telling technology to catch up. And I think the iPhone for me was like this. Touchscreen technology was around for a while, and the first iPhones and Androids were terrible, but suddenly people wanted it and the technology caught up. And I think there's room for robotics there. If we can find those applications, if we can find those examples where people go, oh, and they get excited, they have this vision, the robots aren't quite there, then we can, the technology can catch up. So I also want to mention, Andrea, is now a good time to talk about the online program coming on, or?
I'll come back to you about that, because we actually have a really good question here from Annika. As multi-robot systems become more commonplace, how are we going to address the challenge of allowing a single operator to control many robots in terms of interaction design and cognitive workload? And I'll throw that over to you, Jim.
I have something to say about that. That's a fantastic question. It's a hard problem. We've worked on it a bit. And there seems to be a sense in some of the reviewer community, at least in academics, that this is a solved problem, at least with some of the reviews I've gotten. It's not a solved problem. It's a hard problem. Please keep working on it. The more you can get one person or fewer people to control more robots, the more power we get for search and rescue, for all kinds of different applications. So I'm on board. It's a hard problem.
Oh, excellent. Now, I know, Kerjion, you have something to talk about that I think is a segue from what Jim was talking about more robots for search, rescue, disaster response, and the COVID crisis is definitely considered a disaster response situation. So then I'll come back to you to talk about the program. Jim, do you want to share what you're working on, Kerjion?
All right, so I'm going to introduce a little bit initiative we are doing right now. So actually, I'm the CTO of EXGWare and the co-founder of EXGWare. I'm also a postdoc student postdoc researcher in bioengineering department at University of Pittsburgh. So recently, we have some activity going on that we are conducting a workshop in. Actually, it's in IEEE Roman conference. It's happening this year at August in Italy. As everyone know that Italy is one of the very serious area that the coronavirus outbreak is very people has a very hard time. So I think this year we want to conduct this workshop. Is going to the name is HRI workshop, Human-Robot Interaction, HRI from basic science to new venture creation for social good. So I will talk about what is HRI a little bit later. But this year, this activity, we are gonna call for some project to combat COVID-19 because it's a very good chance, and we have to take initiative at this turning point. All of our researchers should figure out some way to deal with these difficulties, right? So, so as you see this picture, a lot of people, especially in China, they are deploying the robotics to do the help the frontline workers to testing humans' temperature, like body temperature, to identify whether he's get a fever or not. Or some robotics will ask people question on the Times Square to determine whether they have symptom or probably or they has the probability to get contract in coronavirus or not. So I think we need to get some support. I will talk about this later. But at the same time, we also submit the proposal to IROS this year and also ICSR. Hopefully, we can get accepted, so we can have multiple rounds of this workshop going on to solicit more projects to work on this very difficult situation now.
I think it's a great idea to have workshops at all of the upcoming conferences, because I can see there are quite a lot of funding streams that are opening up as well for COVID response. There are a lot of accelerators that are now talking about this. And so this is something that could potentially be another way that industry is connecting to the academic conferences through funding HRI-preneur type workshops. But mindful that we're coming towards the end of the program, and I really want to go back to Tony and to Jim to talk a little bit about the program coming up, because the rest of HRI 2020, it's massive what's been happening going online.
All right, so can you hear me? So I'm in a shared space, so apologies if we have other voices here. So the HRI conference, as everybody knows, was canceled. It's unfortunate that it seems to take more work to cancel a conference than it takes to build one. But we've had a great team, and a lot of the authors have stepped up to make materials. Can you hear me? Tony, maybe you should speak. I'm going to have speaking going in background here.
If you want me to speak, I can. So we've been working on an offline program. We first thought of having a full virtual conference. Turns out that was absolutely impossible, not only logistically, getting people from different time zones to join in, but also just the technology just didn't work. Now, so what we've done is we've asked anyone who had a paper at the conference to pre-record a video. So we have 10-minute videos for full papers, shorter videos, 2 minutes for late-breaking reports, for demonstrations, for design competition entries. And we'll put these online starting with the full papers next Monday, the 6th of April. We've got about 66 videos coming online and a keynote talk by Ayana Howard. And we'll release more videos in the coming weeks. Not to just overload everyone with 200 videos. We'll just have different videos come online every few days, and we'll announce those on the website and through Twitter. We'll also encourage Interaction 3D comments section. All the videos are hosted on the ACM YouTube channel. We'll open the comments section there, and we invite everyone to engage with the presenters and authors of those papers. Ask questions, discuss things, I don't know, question things. Feel free to kind of reach out to these people and have a very public discussion there on the papers. So this is actually the very first event that we've had virtually in conference, and I think I really enjoyed this. Honestly, I'm just very pleased with how this is going, and also very pleased to hear that industry is kind of changing. The interest that industry is taking in HRI is changing. It happened just a few years ago. This change from just, I don't know, mild interest to being really interested in human-machine interaction, with some people coming in to just recruit at the conference. But right now, many companies coming in and really thinking that this holistic approach to a interactive product is important. If you look at why products fail, quite often it is because they didn't take this holistic approach to product design. For example, there was going to be an entire team of Dyson at the conference. They didn't sponsor, they should have sponsored, but they were going to come along because their team leader had a few products that didn't quite work out under his belt, and he wanted to bring people in to see how they could design robotic products that were successful. And he felt that this broad approach to building a technical product was necessary, and so it's just really encouraging to see that our speakers today thought the same thing. Jim, would you like to add something to that?
Yeah, sorry about that. I think I'm controlled my space here now. Yeah, one of the nice things about the video program too, especially for those on the more industry side who might not have attended or might not typically attend an academic conference, is you can view the videos at your leisure. You can browse them. They're freely online. You can share them. They're not going to be behind a paywall, and you can join into the discussions. I hope for those that haven't really engaged the Human-Robot Interaction Conference, this can be a great opportunity for people who are more on the ground building the robots and building the devices, building the products, to look at what the researchers are doing and be able to share and chat with that without having to fly to Cambridge. So if there's an upside to this whole COVID situation, I think it's that this material has become more accessible to the community, hopefully more open as a result.
An excellent kind of finishing note there, pretty much. I did just want to say, hi, Ellen. I see one of my co-chairs has just joined as well. And people are asking about, are the links going online? We're going to put a post up. We're going to put the video up as soon as possible, perhaps on April 6th, maybe as soon as possible, because from the experience of all the co-chairs for this conference, putting things online takes a little bit of extra work. And from ANATH, excited about what's coming up on HRI 2020 soon. The whole conference moving online is a cool human-robot interaction experiment of itself. You are so right. And I do see, for all that we call it social distancing, we should be calling it physical distancing, because we are actually able to have stronger social connections in many ways during this. And we are going to experiment with doing we will showcase the videos, we will set up some more polls and some more online discussion rooms as part of the HRI 2020 ongoing human-robot interaction experiment. And thank you all very much for joining us today.